Hey guys, I'm Emily,
And I'm Sandra.
and this is our project, the Hand Crank Generator.
So, the goal of our project was to construct a functional hand crank generator capable of generating current when the crank was turned. This was done by constructing a rotating magnet that would rotate around a solenoid, which would create potential difference and create current in the wire loop through EM induction. It would create an alternating current, which was converted into direct current with a full wave rectifier.
Our secondary objective, if we were able to complete the main purpose with additional time remaining, was to maximize the current generated by the device, which was measured using a multimeter. So, for a hand crank generator, you turn the crank, you get a current. But how does this actually work? It works through electromagnetic induction, which we can mathematically represent with Faraday's law. So Faraday's law states that E equals negative N d phi over dt. Now, what does this mean? Well, here E is the EMF, the electromotive force, or the potential difference, whatever you want to call it. N is, if you have a coil of wire over here, or a solenoid, the number of turns in that solenoid. And then d phi over dt is the instantaneous rate of change in magnetic flux over time. And this negative sign just indicates direction. It doesn't affect the magnitude. So, but what does this flux part actually mean? Let's break this down. So magnetic flux is equal to the surface integral of B dot dA, where B is the magnetic field and A is relating to the surface area of the solenoid. So right here, this would be our A vector. Well, this is annoying and complicated, so we can break it down for our purposes into BA cosine theta, where theta is the angle between these two vectors. That means in order to have a change in flux, we need to be changing at least one of these variables. And the easiest one, the most practical one to change, would be theta. And you can see right here an example. Our configuration is exactly the same, but it's the same idea where you rotate the magnet and therefore you're changing this angle theta, and therefore you are inducing an EMF in the coil of wire and in the rest of the circuit. So if we take this derivative, if we took a derivative of this expression for magnetic flux, we would actually get, since B and A are both constant in our case, we would get BA negative BA sine theta times d theta over dt because of the chain rule. D theta over dt is omega, the angular speed. So the magnitude of all of this would just be BA omega sine theta. So this is a better mathematical representation of the exact generator, the exact application of Faraday's law that we're using. Now, as you can see here, because of the way this rotates, this is actually going to create an alternating EMF, which is going to result in an alternating current instead of a direct current, which we would prefer.
So, here we have our full wave rectifier circuit diagram. Since the current will be alternating and not direct current, we need this in order to keep the current steady and positive all the time. So you can see how the current is positive all the time by following the path that the current will take. So let's start with a positive current. It'll start from the positive rail here, and it'll go here until this junction. Once it's at this junction, it cannot split off into this branch because D1 prevents the direction of current from going opposite the way it's pointed. So because of that, it has to go on this way. D4 is just like D1. It doesn't let current through, so current has to go this way. It splits off into the capacitor and the ammeter. So therefore, it gives the ammeter a positive reading. The capacitor is here to smooth any dips in current. So when the current goes down to zero, the capacitor will begin to discharge and fill in for the ammeter. Now the current is going to go back to ground this way. So what about when the current is negative? When the current's negative, it's going to start from this direction. It's going to go this way all the way up until this junction. At this junction, once again, we have a diode D2 that prevents direction of current from going in towards the left. So therefore, it has to go through D4. D3 once again also blocks the current from going in the wrong direction. So it'll go this way again. It'll split off into the capacitor and the ammeter, once again giving a positive reading. It'll go back to the ground in the same path.
This is the magnet wheel component of the device. So this wheel was created out of 3mm thick aluminum wire. The handle up here was also made out of aluminum wire, and then 3 small bar magnets were glued to either side of the wheel in order to create a magnetic field. And they're aligned this way with the north on one side and the south on the other side in order to maximize the magnetic field strength compared to if the wheel just had one magnet attached or if the magnets were aligned differently. The base was also created out of aluminum wire. The bottom of the base is meant to be wider in order to distribute the weight of the solenoid. And then there are 2 elevated loops that carry the solenoid up here and the axle for the magnet wheel to turn.
This is the full wave rectifier with the ammeter. The ammeter is placed in series with the rest of the components in order to properly measure current. So here we have the full setup shown. We have the wheel, we have the base, we have the ammeter, and we have the full wave rectifier. Once I plug the ammeter in and I begin to turn the crank, you can see that the reading for the ammeter is 0. This is because the setting is for milliamps and it only goes down to a hundredth of a milliamp. So this time we have only the wheel, the base, and the voltmeter. The voltmeter is measuring the potential difference throughout the solenoid. As I turn the wheel, you can see the measured value for volts change. It alternates from positive to negative, which reflects the alternating current that is created. Overall, the generator was successful. Though the ammeter did not measure a current, there was an EMF that was measured by the multimeter.
Some of the future improvements that can be made to the generator in order to have it generate more current would be to use bigger and stronger magnets in order to create a stronger magnetic field, to use an actual wheel and stand to provide some additional stability to the device so that it could support a larger solenoid, use a solenoid with greater surface area or more loops to increase the EMF induced, and as to use a more precise ammeter. That way we can measure what current is actually being generated below the milliamps level of precision. Thank you for listening. This was our project, the hand crank generator.